Azure Firewall. So in this session, we are going to understand how exactly this Azure Firewall comes in place for either allowing or blocking the traffic. But before that, we have already covered NSG, Network Security Group. And through Network Security Group, we were already able to restrict the traffic inbound and outbound. So how is firewall going to be different? Now in NSG, we don't have ability to allow or block on the basis of domain name. For example, I don't want a virtual machine which is in the VNet to be able to browse something like www.facebook.com, or should not be able to browse certain banned websites. Or if you take it the other way, the firewall should allow only certain selected websites which are valid for corporate and probably ban all other websites. So if this is a kind of requirement, we have to now meet that using Azure Firewall. We can't do this using NSG rules. NSG rules will work only on the basis of IP address, port number and protocol, but will not work on the basis of domain names. So how can we configure firewall, and in what context it will come into the picture? Not always, of course. In what context it will come into the picture is what we'll have to see here. Now it's a service which will take a lot of time to create. So first I'll start with creating a firewall. Now, but before creating a firewall, we would be required to create certain policies. But what I'll do is I'll first create a firewall and then I'll create the policies. And even before I create a firewall, we will have to first go to the virtual network, and in the virtual network we have to create a subnet by name Azure Firewall Subnet. So let us say, I'll just show you the error first. We have to first create a policy. Azure Firewall. The virtual network must have a subnet named Azure Firewall Subnet. So that is supposed to be the starting point. Go to virtual network. In virtual network, go to subnets and add here Azure Firewall Subnet, and we may leave this 0.0 as it is. For the firewall subnet 192.168.0.0/24, I'm leaving it as it is. Click on save. Now go to the firewall and here select the resource group. Let's say I want to use this for demo East US VNet firewall. So East US zone availability we don't want, and I'll keep it as basic. Now premium supports additional capabilities. These are mostly application gateway kind of facilities, SSL termination or the distributed attacks. We don't want all that. We just want to understand how to configure. For that, standard is good enough. Actually, basic is really very basic. So I'm not teaching basic, I'm teaching little better. That is standard. You see, in basic, we don't have this option. Policy manage or classic. In standard, we have this option. So I'm going with standard, and I would like to have firewall policy to manage this firewall. Now, what is this firewall policy? It is in this policy only we are going to provide all the rules. Now, earlier what they did in the classic was policy, that is the rules and firewall was together. So we did not get reusability. If suppose I have 10 VNets and for all 10 VNets I want to use same policy rules. For my organization the rules are common. So 10 VNets cannot use the same firewall. All 10 VNets will have to use their respective firewall. So 10 firewalls. Now instead of replicating the same set of rules in each and every firewall, we'll have a policy separately, bind it to the firewall, and the rules can be reused in multiple firewall. That is the idea behind a firewall policy to manage this firewall. If the policy is already there, we can use that. But because we don't have, we are going to create a new policy. So let's say demo firewall policy. Now it's not tied up to any particular VNet, but it has definitely got a region. Click on OK. So we have got a policy to be created, demo firewall policy. Choose the VNet. We already have the VNet, we'll choose that. We don't want to create a new VNet. IP address. If you want, you can create a new IP address. Ideally, yes, I'll do that. VNet IP. I'm giving the name as Demo East US VNet Firewall IP. That means to the name of firewall, I just suffixed IP. Forced tunneling. Now this is going to be used especially when your VNet is connected to on-premise and you want all the routing to internet to go via a virtual appliance which probably is present in on-premise. Your traffic should go to on-premise and from there it should go to internet. In those kind of cases, you may want to have the forced tunneling enabled. I don't want that. We don't have on-premise connection also at this point of time, but this is it. With all this configuration, I would like to create a firewall. Review and create. Now this is, I'll just wait for the create button. Don't shift over, just stay on this page. And it's going to definitely take some time for the firewall to get created. Now what are the key features of firewall? Controlling outbound network access is an important part of overall network security plan. For example, you may want to limit access to certain websites. But not only websites, firewall has the ability to do everything what we can do with NSG. You may want to limit the outbound IP address and ports that can be accessed. Now with firewall, three types of rules can be created. You can configure application rules, network rules, NAT rules. Now what is the difference between each one of them? Application rules are basically restricting certain websites on the basis of the domain name. As I told you earlier, we may want to restrict www.facebook.com. We may want to allow google.com. Certain websites don't want to allow ChatGPT, block the URL of the ChatGPT. So we want to block domain names. We want to block access to certain web address. So that we can do using application rules. Then we have got network rules. This is precisely like NSG. It's same as NSG. You're going to block on the basis of protocol, source IP, destination IP, source port, destination port. Very similar to that of NSG. Now, firewall is a stateful service. Now, what does it mean? Suppose let's say this is my VNet. And I have put firewall in one of the subnet. This is my firewall subnet. And let's say we have got some other subnets, front-end subnet, back-end subnet, whatever other subnets are. And inside that I have a VM. Now firewall is going to get created here. This is firewall. Let us assume that right now we are browsing internet like this, direct. We don't want this. We want the request now to go to firewall, and from firewall we should be able to go to internet. After maybe a verification that it should be allowed or denied here. So every request from the virtual machines of this subnet for internet should send the request to firewall. Now, when do you think this is possible? Obviously, only if in the subnet we have got a route table. For the subnet we have a route table, and on that route table we created a rule that all outbound traffic should be routed via firewall to internet. Now the moment you do this, you may want to probably allow traffic or deny traffic based on certain conditions. Now what firewall does is, if you block traffic to outbound, automatically inbound will get blocked. Basically what should happen? Imagine if my machine is here, right? If my machine is here. Now what I did, because of the firewall in place, I'm able to block the inbound traffic no. Inbound traffic always comes like this. Because my machine is here on internet, my inbound traffic would be directly from internet. Route table doesn't come into picture for inbound traffic. Now from here, if I go in, to get the exit, it has to go like this via firewall. Now when will a connection be treated as completed? When I submit a request and I get a response, I'm going to treat that connection as success. Now because the outbound traffic is blocked like this, ability to send the request is there, get the response is not there. Now firewall will block it. That means if you have created a deny rule in firewall, it's not only going to work for outbound, but it automatically works for inbound. This doesn't happen in NSG. In NSG, inbound rules are absolutely different and outbound rules are absolutely different. Inbound rules, if created, they don't have any impact on outbound rules. And outbound rules created, they don't have any impact on inbound rules. Firewall is not like that. Because you are not able to get the response, firewall will block it. Because you are not able to get the response, the circuit doesn't complete. The connection doesn't complete and we will not be able to browse it. That is when we are going to use NATing. NAT rules will come into the picture. So what we'll do is we'll send the request to a particular port of the firewall and ask firewall to send the request inside the network, get the response from the network, one of the virtual machines, and then give it to us. We'll go via a NAT port. Now how to do this? I'm going to show you with proper example. But what are the key features? The key features of Azure Firewall, it is managed. The entire service, you don't have to create virtual machine. You don't have to worry about increasing load in your network. You don't have to scale. So cloud-based network security service that protects your entire virtual network, all the resources. It's a stateful service. That's what I explained just now. With a built-in high availability. High availability means automatic replication, resiliency is built into it. It will not go down. Internally, Microsoft ensures that your firewall is always going to be available. And unrestricted cloud scalability. Any amount of request coming in, they can be absorbed by the firewall and the request can go inside the network or outside the network. The inbound outbound traffic is not limited to a particular number. That's what I meant by unrestricted cloud scalability. It can scale. Obviously, more it scales, the more cost you pay, no doubt about it. But we don't have to manage that scalability aspect. That's why it is a managed service and a stateful service with high availability and unrest. These are the three main characteristics of Azure Firewall, why the organizations can directly make use of it. It can scale up to as much as you need to accommodate the network traffic flows. So you don't need to budget for the peak traffic. Sometimes the traffic is low, you are going to be billed less. Some of the traffic is very high, you're going to be billed more, but you don't have to specify always this will be the limit. I mean, what happens otherwise is if you specify lower traffic budget on higher traffic, it might become a bottleneck. It might throttle. So we don't want that throttling. We don't have that ability actually. It automatically scales up and scales down. Application, fully qualified domain name rules can be created, which are for HTTP and HTTPS traffic. And you don't have SSL termination requirement for this kind of stuff. And of course, if you go for premium pricing, you have SSL termination. Now, what is this SSL termination? The request might come to firewall with HTTPS, and HTTPS decryption can be done at the firewall level, and it can become a HTTP request inside the network. From outside HTTPS, from inside it is HTTP. So the primary web server doesn't have to take care of the decryption. It can directly execute the request and generate the response. So that feature of course is only in premium pricing. You have got threat intelligence based filtering. If there is some kind of access to your network, some kind of malicious IP address attack. See, what Microsoft is doing is, because they have this global presence and people are continuously using it, they are doing some kind of machine learning. And because of this machine learning, there are a lot of IP addresses which they will report it as malicious. Suppose some IP address is continuously sending request for login. They know it is a bot, and immediately they will mark that as a blacklisted IP address. Or they will have a database of such kind of locations from where the requests are not going to be considered as safe. So in those kind of cases, the firewall will have this built-in intelligence and it can filter such traffic. It will not even allow such traffic to go in, which are updated in real time to project against new or emerging attacks. Microsoft is managing it in real time, that particular thing. Yes, if needed, firewall can have multiple IP addresses. Why that is needed, I'll show you. You can integrate with Azure Monitor, that's a monitoring service for monitoring various kind of events and to read the logs. Yes, you have got Azure monitoring integration. Firewall policy can be associated with firewall across region. See, I created a policy in East US. but not necessary that the policy should be used only with firewall in that region. I can use the policy created in one region for multiple firewalls in different regions. And that's how the benefit. My organization has a VNet in India, I have VNet in UK, and let's say in US, one of the regions. For all the three, I can use the same policy. The ideal purpose of policy itself is reusability, and that itself can be made as hierarchical. You can have one parent policy which is common for all the regions of the organization, and then you can have a child policy which is for a given region, and child policy can be attached to a firewall. So think of a virtual network which has got not only the main hub, but also it has got maybe spoke. So there will be one VNet. Let us think of that as a hub or master VNet, and from there all these are spoke VNets, one master and many spokes. And I'm going to teach this, how to set up master and spokes in VNet configuration, VNet connectivity. And in the hub network, I've set up the firewall. User configuration, L3, L7 connection policies, application level policies, threat intelligence, malicious IP blocking, domain name based filtering. All these are features of the firewall. NATing, traffic is denied by default. You have to allow whatever is supposed to be passed through. You can have a firewall configured to integrate with on-premise also. So what we are going to do is, I already created the firewall. Yes, it is a rule. Azure firewall must be in the same resource group as the VNet. So I have front end and I have back end. And we have already seen this part, how a front end traffic is routed to back end via virtual appliance. From front end, every traffic goes to virtual appliance, and from virtual appliance, it goes to the back end. Now let's think this is internet. I want to now let all the traffic of the front end go via firewall to internet. So definitely first I should create a firewall, and the IP address which I am going to get for the firewall, I'll use it for the outbound rule, which I'm going to create in the route table for destination address 0.0.0.0/0. In the previous session, I showed you how we can simply block traffic to internet via route table. Now instead of blocking, we are now sending it to the firewall, and from firewall it will go to the internet. So for this, I have my firewall created. We don't have much to do in this particular firewall right now because the policy is attached here, managed by firewall policy. Here, firewall policy. To edit the firewall policy, this is the policy, demo firewall policy. And you can see here, we can have a parent policy. If this is a child policy, we can attach it to the parent policy. Every rule which is there in the parent policy automatically is inherited by the child policy. And you can see this is application rules, network rules, DNAT rules. All the rule collections are going to be shown here. Now what I'll do is I'll straight away go to application rules. Now before this I should demonstrate to you I go to the Web1 VM and connect to the Web1 VM using Bastion. Now if Bastion is not there, you might have practiced and deleted. Use RDP. Like this. I also go to database 1 VM and Bastion. Right now from Web1 VM, let's check if we are able to browse internet. And same thing I should do from database VM. So I am able to get this page itself, means I am able to browse. Type www.google.com, working, facebook.com, working, right? All websites are working. Confirm it from database 1 VM, which is in the backend subnet. If you remember in NSG session, we have blocked the traffic. Outbound traffic from this, we have blocked it. But that's blocked not on the basis of domain name. We blocked on the basis of IP address. So if you go to
No, you can not serving.
Go to networking, and in outbound rules we have deny internet outbound. Now for some reason I'm going to delete this rule. Remember, only NSG rules which we created we can delete. The built-in rules we cannot delete. Now after deleting these rules and few more seconds, from database 1 VM also we will be able to browse internet. This will start working. Fantastic. It did not even take any time. Google.com. All working. So from Web1 VM we are able to browse internet. From database 1 VM we are able to browse internet. Now I go and create a policy. That is, I am now creating a application policy. Basically we have to create a application rule. From this particular source address, https target google.com, we want to probably allow or deny, something like that we will have to do. So what I'm going to do is slightly different than what you see here. See, first thing right now, firewall is not coming into the picture because I have not used firewall in any of the route table or the route rules. I have not used it. So what to do? Go to the route table. Go to your route table. Front end UDR. This I have attached to the front end subnet. That means only for outbound traffic from front end subnet. I create a route. I'm adding a new route. And here I'm saying internet via firewall. So destination address, I'll give 0.0.0.0/0. Next hop, a virtual appliance has to be taken. And now I should give the IP address of the firewall. Now what can be the IP address of the firewall? Now the IP address of the firewall will be 192.168. Now what is the subnet we have used? 0.0. So 0. The first resource I created in that is 4. 192.168.0.4, which is the IP address of the firewall. So now what does it mean? Once this rule is created, all outbound traffic from a subnet to which this route table is attached, which is front end subnet, should now get routed via firewall. So go to the Web1 VM and try to refresh. Not working. But database 1 VM, refresh. Working. Why? Database 1 VM is in backend subnet and route table is not attached to the backend subnet. NSG is also not blocking the outbound traffic to internet anymore. So again I repeat, the rules are only for outbound. The rules are only for outbound. Now on Web1 VM, we remember placing a web server. Are we able to browse that web server? So for this I have to find out what is the IP address of Web1 VM, the public IP address. This is Web1 VM. And this is the public IP. Not working. Why? Even though I will be able to go inside, I am not able to come outside. Any traffic, I am on internet now. My machine is on internet. There is no problem in inbound traffic. But the outbound traffic is blocked. By default, firewall blocks everything. So how to solve this problem? I am not able to browse any website once the firewall is in place. I am not even able to access the virtual machines which are inside the subnet. The subnet VMs all got isolated from internet now, just because I have created one rule in the user defined route table. I am routing outbound traffic of all the VMs in the subnet, front end subnet, to go via firewall. This is the culprit. Not a culprit, this is the protector actually. Now what we will do, whatever we want to allow, we will go and allow in the firewall. But don't do it in the firewall, we have to do it in the policy. This policy we have already attached to the firewall. So I want to first solve the outbound traffic from the virtual machines to internet. So I'll first create a rule. Here you have add a rule collection, and inside that a rule has to be created. So I'm adding a rule collection. Application rule, DNAT rule, network rule. I am interested in application rule. Allow all websites. I'm doing reverse. And I'll give this as the highest priority. Sorry, I'll give this as the lowest priority. Allow all websites, allow. And there is a default collection group. I'll just leave this as it is. Default application rule collection group. And I'll give here all websites. Source any IP, so star. Protocol any. Fully qualified domain name any. Or let's be specific, 80. Protocol HTTPS and HTTP. All websites from any source to any destination, and the protocol and ports of HTTP and HTTPS. The default port of HTTPS is 443. The default port of HTTP is 80. Both allow. Otherwise you can write like this also. HTTP colon 80, HTTPS colon 443. Even that way you can write. And add. The moment I create this rule, once the rule is successfully created, I will be able to go to this VM and start browsing internet again. All websites I have allowed. You might say only these websites are allowed, and straight away create them, or do it the way I am doing it. First allow all the websites and then start denying the websites which you are not interested, which we want to blacklist or block it. You have no choice but to wait. This rule should be created and then only we can proceed. Done. And the rule is already in place here. Now go here, Web1 VM. See, already available. All websites you can visit now. No restriction. All perfect. So now what to do? Now in the application rules, I'm going to add one more rule here. All perfect. So now what to do? Now in the application rules, I'm going to add one more rule here. But this is allow. No, I don't want to add to allow. I want to add to deny. So cancel this. Add a rule collection. Deny websites. Change this to deny. And give better priority than the earlier one. And it should be minimum 100. So I'll give 1000. The collection rule is application rule collection group. Group is same. Now let's say I want to deny Facebook from any machine. That means all the machines which are in that particular subnet. Or you can restrict it to few machines only by putting their IP address. I can write here 192.168.0.4. So only that web 1 VM it will get applied to. Because I'm putting star, it becomes all the VMs in that subnet. So for that, HTTP and HTTPS, I want to deny to star.facebook.com. Like this. Actually speaking, here itself you can add one more rule. Or if you want to keep it separately, you do it here. So give a list of websites which you want to block it. Let's say ChatGPT. From any machine, HTTP, HTTPS, chat.openai.com. Add it. And wait for this rule also to get created. So one rule I created where I'm allowing all, and the other rule I'm creating only the selected websites I'm denying. So entire world, all the websites are by default accessible. That's a low priority rule. Successfully added. And now we have all the three rules successfully added. This is allow, low priority, and deny, better priority. Now check up. Refresh. This should work. Yes. Facebook blocked. Chat.openai.com blocked. Google allowed. So this is how we implement application rules. These are all application rules. You can of course edit. You see now there are two rule collections here. This is one which is allow and this is deny. Now in case we want to edit the rule collection deny, right now from here we can edit individual rules. I can make changes to individual rules. But if the entire rule collection has to be edited, go here to rule collections. We created two rule collections under a application rule collection. Now application rule collection itself has priority, and in that these are the priority. All websites, I can add more. Deny websites, I can add or delete or edit. So navigation is little tricky. Here you are only adding the application rule collection. You will not be able to edit. A collection of application rule collection, a collection of application rule collection is what is application rule group. That is group, and group can be created from here. Rule collection group is the highest level. Under rule collection group we have got rule collection, and under rule collection we have got rule. Rules don't have priority. Priority is only for rule collection and collection group. So always it will try to first take high priority collection group and see if there is a rule collection with rules matching. If it is not there, then it will take to the next rule collection group and so on. The priority works first at the collection group level and then inside the collection group for collection. So 2 levels of priority. So if there is one more rule created with priority, let us say 400, these rules will be checked first and then the priority 400 rules will be checked. Higher the number, lower the priority. Smaller the number, higher the priority. Keep this point in mind. But yes, we are able to make the application security group work here. So one problem solved. That we are not able to browse, that problem is solved. We are now able to browse entire internet except few selected websites, which are, let's say, banned websites. Now how to solve this problem? I'm not able to browse the machine. This is where we are going to make use of the NAT rules. Destination NAT rule. We can call it as DNAT. So I'll create a DNAT rule here. For accessing, let's say, web servers. Priority collection group DNAT. Now source IP. I'll give here source IP as star. Protocol, I would like to support TCP. Destination port 80. Destination firewall IP. We know that firewall IP is 192.168.0.4. Now, if a request goes from a source on this port of this IP, which is firewall IP, to which machine should I send the request to? Translated address. I want to send the request to 192.168.0.1.4. The web1 VM IP this is. And translated port is 80. We are basically doing NATing. This is called as NATing. I'm sending the request to this IP, this port, which is firewall IP, and it's forwarding the request to the private IP address of the web 1 VM, same port. Now this is giving error. Now what it needs is firewall public IP is needed here. I give private IP, but this is supposed to be firewall public IP. So find out first what is the firewall public IP. We have used public IP for the firewall. Copy this. And that's supposed to be given here. Now it's fine. Public IP of the firewall is what I'm going to send request to. See, private IP I can't send request. So when I send a request to the public IP of the firewall on port number 80, firewall will forward the request to port number 80 and private IP address of the web server. And this is what? Web server 1. I'll call it as NAT servers. NAT rules. Let's call it as simple NAT rules. So only port number 80 I'm allowing now. Okay, let's create this first. We have to wait for the rule to get created. After the rule will get created, this will start working. So how is it going to work now? My request doesn't go to web1 VM. My request goes to firewall, public IP address of the firewall. Firewall will send the request to web server, web1 VM. Web1 VM will generate the response to firewall. Firewall will generate the response to the machine, which is on internet. Let's say my machine. And this will start working after a while. Once the rule is created, this will start working. We'll have to wait for the rule to get created. But right now I have allowed only one rule, which is HTTP. Now what if I want to do RDP? Even RDP will be gone now. Though in my VNet I am able to do HTTP request, because I am sending the request to port number 80 of the firewall and that's forwarding it. Same thing we will have to do for RDP also. I will not be able to do RDP to the virtual machine right now, because to get the response again it has to go via firewall only. The virtual machine web1 VM has public IP. Web1 VM has public IP. And if I try to do, and you see networking, I have allowed HTTP, I have allowed RDP also. Right now I am connected via Bastion, but if suppose I go and I try to connect via RDP, here it says inbound network security group has created and client IP address can access the port. But let's try. It's an inbound request. My request will go to web1 VM, but my machine is on internet. The response of web1 VM to internet is via firewall, and firewall by default will block it. It will not allow. We'll solve one at a time. Now let's go back and check, is this rule created? Yes. Now can we browse? Not working. Why not working? I'm sending request now to the public IP address of the Web1 VM. No, we are not supposed to send request to the Web1 VM. We are supposed to send request to the public IP address of the firewall. So on this address, this port will forward the request to this address, this port. DNATing, this is called as. Destination NAT, this is called as. So I copy this and I use this now. And I'm getting it. It's the response from my web server, which is in Web1 VM. Now there is a problem. What is that? RDP. We are not able to do RDP. Let's solve that problem first. I want to add a rule. Into this rule collection, I would like to add a rule, DNAT rule, RDP to Web1. Source from anywhere, destination, I'll give the IP address of the firewall, protocol, RDP uses TCP, destination port 3389. Should translate to an IP address 192.168.1.4, which is the IP address of Web1 VM, and translated IP is also 3389. Save it. Once this is done, we'll check if we are able to do RDP. And we should be able to. We are NATing. We are going to firewall and firewall is able to forward it. But then there is one more problem. Let us see the solution to this problem and then we will go to the next problem and try to solve that also. No choice but to wait. Wait for this rule to get created. The rule is created. Let's see if this is working now. Web1 VM, download RDP file. It's already there actually. Open that. Connect and not working again. Why? Same problem. I'm sending request to the IP address of the VM. IP address of VM, it will not work. We have to send the request to, go and search and type RDP on the desktop. Send the request to IP address of firewall and do connect. And it works. This window itself means it's working. I have to just give username and password and click on connect. I'm cancelling it. But what is the problem? The problem is, what if I have Web2 VM? If I send request to this IP and this port, it is connecting to very clearly Web1 VM IP and port number 3389. This IP and this port is connecting me to Web1 VM. But what if I have to connect to Web2 VM, which is also imagined in the same subnet? This will not work. So what we should do, we have two options. One is, to the firewall, you attach one more IP address. definitely you have to take the cost of one more IP address. That is additional cost. IP addresses are not free. And choose that IP address for Web2 VM. Or the good option would be don't give IP address for Web1 VM or Web2 VM. Right now, Web1 VM, Web2 VM have public IP address. Waste. We can't use them now. We can't reach this public IP anymore. So you can detach it. You can go to the networking, Web1 VM networking, Web1 VM VNet, network interface, IP configuration, select the public IP, IP config 1, and select the public IP here and detach it. Not available from here. IP config. The UI is slightly changed. Okay, so I go to public IP address, Web1 VM. It's right now associated with Web1 VM and its corresponding NIC. Disassociate. Same thing you do for Web2 VM. I'm not doing it. Same thing you do for Web2 VM. That means you're not having public IP address for VM now. You'll keep adding IP address for the firewall. A firewall can have multiple IP addresses. If I go to firewall, here I can add multiple IP addresses. There is only one right now. I can detach from Web1 VM and attach here. This is free right now. This is not used anywhere, so I can attach it. I'm not doing it, but telling you this is how it can be done. So once you have multiple IP address, every public IP address of the firewall can map to a different VM in the VNet. Or edit this rule. On the same IP, if you edit, you can say 3390 is mapped to this Web1 VM. 3391 is mapped to Web2 VM. 3392 is mapped to like that 89909192. Change the port number. See, you have to change the combination. You have to change the destination IP and port number combination. You have to make it unique. And this combination can refer to the corresponding translated IP combination. This you keep it as 3389 only. So you can use same IP for different port, send to different backend machine, same port 3389. Keep this 3389 because VM is having RDP listening on only 3389. So that can be an option. You can go to edit rule, change it to 3390. Click on save. Once you do this, the only point is when you're using a RDP client, once the rule is updated, when you're using RDP client, when you mention the public IP address of the firewall 172.190.246, by default this will send the request to 3389. Now if it has to send the request to 3390, you have to type here 3390. You have to take care of that. Explicit port number has to be mentioned. Translator, NATing, network allocation table, network translator it is. NAT tables are basically for mapping the source IP and port to any destination IP and port. Most of the time, but not necessary, the source IP and port are public. The source IP is public. Most of the time the destination IP is private. So the now request goes into the web server. with the IP address of public, the load balancer public IP, and the response comes back that way only. So this is how you can configure more than one VM RDP port, more than one VM AT port, use same IP or different IP. Like this, if you want to actually create NAT rules, generally NAT rules become very important, network rules become very important when we have got a custom DNS. Right now we don't have a custom DNS server. I'm not putting any one machine of my network as DNS. But if suppose I have any one of the machines as a DNS, then in such case this is going to be a problem. So what we can do is add a rule collection now. Let's say this is for DNS, or I would call it as network rules. Collection type is network. This I'll use network rule collection group. Priority. Give your, let's say, Google DNS. So I'll give your source IP as star. Protocol UDP. For DNS we use UDP. Destination port any. Actually 53 is the destination port for DNS. And let's say 8.8.8.8. So we are allowing access to DNS. This is DNS server by Google. This is the DNS server by Google. Like that, if you want to have one more DNS server configuration, you can do that. So basically, by default, all NAT rules suppressed. I'm allowing now whatever rules I want to. Not NAT, sorry. Network rules. Outbound network rules. We are saying Google DNS server is accessible. So this can be one more addition you may have to make. If suppose your virtual machine is not able to access the DNS server. As of now, no problem is coming because we are having a built-in DNS server of VNet. We can change that DNS server to our own custom machine, or we can say we don't want to use the DNS of our own. We want to use the DNS which is already on internet, 8888. Yes, you can do that. So now the moment you restart your virtual machine, you want to use 8888 as the DNS server. How to do that? Go to VNet. And in VNet we have got DNS servers. DNS servers. Default Azure provided is working right now. That's why no problem. Change this to 8888. This is on internet. So actually, if this is the case, that rule should be created. Network rule should be created. If you have changed your DNS server to some custom DNS server which is on internet, network rules should be created to allow access to that DNS server by way of its IP address. So three different rules we have seen. Application rules. In firewall I do nothing actually. Everything we did was in the policies. firewall policy. We have seen application rules, which are domain based, NAT rules, which are IP based, and DNAT is not for allow or deny, DNAT is for translation. RDP or HTTP to web server translation, DNAT, destination NAT. And there are many more. Threat intelligence. You can configure DNS settings will be applied to this policy. If you want to have TLS inspection, SSL, see right now threat intelligence is alert only. It will not deny, it will just alert, it will log it. You will receive a high confidence alert for the traffic going through firewall or from a known, from known malicious IP address and domains. The intelligence will not filter traffic to any IP address. So by default, what is configured by Microsoft is denied. Suppose I do this. Now you want to allow. You can put here allow list of addresses. So basically from the list of blacklisted IPs, we are listing some IPs as whitelisted. Same thing with domain names. Allowed list addresses. Will not filter the traffic to any of the IP addresses. So threat intelligence. This will come only with premium. Something to do with intrusion detection and prevention. Organization level intrusion detection, if you want to do maybe something which I'm not really aware of. You may want to go more deeper, explore the other options here. So again, I repeat, policies can be in any region and can be attached to a firewall of a given region for that particular VNet. Firewall and VNet should be in the same resource group, obviously in the same region. Firewall can go only in a specific type of subnet, that is Azure Firewall Subnet. Within the VNet, Azure Firewall Subnet. Firewall cannot be reused for multiple VNets. Every VNet should have its own firewall. And every policy can be inherited from another parent policy. So at the parent level, we can have organization level policy. And then at the VNet level, we might have region level policy in case we want to. So we have to create multiple policies and simply attach them to the respective firewall. One firewall will have one policy. One policy can be used with multiple firewalls. And last but not the least, firewall is pretty expensive service. If you have created and if it is not for real time, do whatever you can in a stipulated time period and delete it instantly. There is no option to disable a firewall. It's very expensive. If you are working with something like a free tier account or some shares, in less than 1 day your account can get deactivated. You might end up using all the free credits and less than 1 day the account would get deactivated. And that is the reason in our shared subscription we don't allow you to practice this topic. You will not be able to. You have to probably watch the video a couple of times, understand, I've covered all possible cases, and try on your own in case you have your own subscription, which can be free trial or your own Visual Studio Enterprise subscription, or you may want to go for pay as you go, which is definitely not something which I advise. But in Technsoft shared subscription, we don't want to allow practice for firewall. It's pretty expensive. You're not supposed to do this. That's all in this particular session. Thank you.